Section 110.12c addresses the integrity of electrical equipment and connection. This standard emphasizes the importance of maintaining electrical equipment in good condition to ensure safe operation and prevent electrical hazards. The requirements outlined in this section focus on two key aspects: the cleanliness and condition of internal parts and the replacement of damaged components. Firstly, regarding internal parts, the standard specifies that busbars, wiring terminals, insulators, and other internal parts must be free of damage or contamination from foreign materials. These foreign materials include paint, plaster, cleaners, abrasives, or corrosive residues. The presence of such contaminants can compromise the insulation properties of insulators, reduce the conductivity of busbars and terminals, and accelerate corrosion. For example, paint on a busbar can act as an insulator, increasing resistance and causing localized heating. Plaster or cleaners can introduce moisture and corrosive elements, leading to corrosion of metal parts. Abrasives can scratch and damage surfaces, reducing their ability to withstand electrical stress. Corrosive residues, such as those from cleaning agents or environmental exposure, can degrade the metal components, leading to premature failure. To comply with this requirement, regular inspections and cleaning of electrical equipment are necessary. During these inspections, any foreign material should be carefully removed using appropriate cleaning methods and materials that are compatible with the equipment. It is crucial to avoid using harsh chemicals or abrasive cleaners that could further damage the internal components. Secondly, regarding damaged parts, the standard mandates that damaged parts that could affect equipment safety or mechanical strength must be repaired or replaced. This includes components that are broken or cracked, bent or deformed, corroded, or deteriorated by chemical action or overheating. Broken or cracked components can create sharp edges or expose internal conductors, posing a shock hazard. They may also compromise the structural integrity of the equipment, leading to instability and potential failure. Bent or deformed parts can disrupt the proper alignment of components, affecting their function and potentially causing short circuits or other malfunctions. For instance, a bent busbar may come into contact with another conductor, creating a fault. Corrosion-damaged components can weaken the metal parts, reducing their ability to carry current and withstand mechanical stress. Corrosion also increases resistance, leading to localized heating and potential fires. Parts deteriorated by chemical action or overheating can become brittle and prone to failure. Chemical exposure can degrade the insulation materials, reducing their dielectric strength and increasing the risk of arcing. The overheating can anneal the metal components, reducing their tensile strength and making them more susceptible to deformation. To ensure compliance with this requirement, regular inspection should include a thorough examination of all components for signs of damage or deterioration. Any damaged parts should be promptly repaired or replaced with approved replacements. When replacing components, it is essential to use parts that are specifically designed and rated for the equipment. Using incorrect or substandard parts can compromise the safety and performance of the equipment. Furthermore, proper torquing of connections is vital to ensure reliable electrical contact and prevent overheating. Loose connections can create high resistance points, leading to localized heating and potential fires. Therefore, all connections should be tightened to the manufacturer's specified torque values using calibrated torque wrenches. In addition to these specific requirements, the standard also emphasizes the importance of following the manufacturer's instructions for maintenance and repair. These instructions provide detailed guidance on the proper procedures for inspecting, cleaning, and repairing the equipment. They also specify the types of cleaning agents, lubricants, and replacement parts that should be used. Following the manufacturer's instructions is essential for ensuring that the equipment is maintained in accordance with its design specifications and that the safety and performance are not compromised. In summary, Section 110.12c plays a critical role in ensuring the safe and reliable operation of electrical equipment. By maintaining the cleanliness and condition of internal parts and replacing damaged components, electrical hazards can be significantly reduced. Regular inspections, proper cleaning methods, and adherence to the manufacturer's instructions are essential for complying with this standard. Failure to comply with these requirements can result in electrical shocks, fires, equipment failures, and other serious consequences. Therefore, it is imperative that all personnel involved in the installation, maintenance, and repair of electrical equipment are thoroughly familiar with the requirements of Section 110.12c and that they take the necessary steps to ensure compliance. This includes providing adequate training to personnel, establishing clear procedures for inspection and maintenance, and providing the necessary tools and equipment. By implementing these measures, organizations can create a safer and more reliable electrical environment, protecting their employees, customers, and assets. Now, let's delve deeper into specific scenarios and best practices related to Section 110.12c. Consider a situation where an electrical panel is located in a dusty industrial environment. Over time, dust can accumulate on the internal components, including busbars, wiring terminals, and insulators. This dust can act as an insulator, reducing the efficiency of heat dissipation and potentially leading to overheating. To address this issue, the panel should be regularly inspected and cleaned using a vacuum cleaner or a soft brush. Compressed air can be used to remove dust from hard-to-reach areas, but it is important to use it carefully to avoid blowing dust into other sensitive equipment. In addition to dust, other contaminants such as oil, grease, and moisture can also accumulate on the internal components. These contaminants can attract more dust and create a conductive path, increasing the risk of short circuits and ground faults. To remove these contaminants, a suitable cleaning agent should be used. The cleaning agent should be compatible with the materials of the components and should not leave any harmful residues. Before applying the cleaning agent, it is important to disconnect the power supply to the panel to prevent electrical shocks. The cleaning agent should be applied sparingly and allowed to dry completely before restoring power to the panel. Another common issue is corrosion of metal components. Corrosion can occur due to exposure to moisture, chemicals, or corrosive atmospheres. Corrosion can weaken the metal components, reduce their conductivity, and increase their resistance. To prevent corrosion, the metal components should be protected with a suitable coating or sealant. The coating or sealant should be resistant to moisture, chemicals, and other corrosive agents. In areas with high humidity or corrosive atmospheres, it may be necessary to use corrosion-resistant materials for the electrical components. For example, stainless steel or aluminum can be used instead of carbon steel. Regular inspections should be conducted to identify any signs of corrosion. If corrosion is detected, the affected component should be cleaned and treated with a corrosion inhibitor. In severe cases, the components may need to be replaced. Overheating is another major concern in electrical equipment. Overheating can be caused by loose connections, overloaded circuits, or inadequate ventilation. Overheating can damage the insulation of wires and cables, reduce the life expectancy of components, and increase the risk of fires. To prevent overheating, all connections should be tightened to the manufacturer's specified torque values. The circuit should be properly sized to handle the load, and the equipment should be adequately ventilated. Regular inspections should be conducted to identify any signs of overheating, such as discolored wires, melted insulation, or burned components. If overheating is detected, the cause should be identified and corrected immediately. This may involve tightening connections, reducing the load on the circuit, or improving the ventilation. Damaged parts should be replaced with approved replacements. When replacing components, it is important to use parts that are specifically designed and rated for the equipment. Using incorrect or substandard parts can compromise the safety and performance of the equipment. For example, using a fuse with a lower current rating than the original fuse can cause the fuse to blow prematurely, interrupting the power supply. Using a wire with a smaller gauge than the original wire can cause the wire to overheat and potentially start a fire. All replacement parts should be properly installed and tested to ensure that they are functioning correctly. The manufacturer's instructions should be followed carefully during the installation process. After the installation, the equipment should be tested to verify that it is operating safely and reliably. In addition to these specific scenarios, it is important to consider the overall environment in which the electrical equipment is located. The environment can have a significant impact on the performance and lifespan of the equipment. For example, electrical equipment located in a damp or humid environment is more susceptible to corrosion. Electrical equipment located in a hot environment is more susceptible to overheating. Electrical equipment located in a dusty environment is more susceptible to contamination. To protect the electrical equipment from the environment, it may be necessary to use enclosures or other protective measures. The enclosure should be properly sealed to prevent the entry of moisture, dust, and other contaminants. The enclosures should also be adequately ventilated to prevent overheating. Regular inspections should be conducted to ensure that the enclosures are in good condition and that they are providing adequate protection. Furthermore, it is important to have a comprehensive maintenance program in place for all electrical equipment. The maintenance program should include regular inspections, cleaning, testing, and repairs. The maintenance program should be tailored to the specific needs of the equipment and the environment in which it is located. The maintenance program should be documented and followed consistently. The maintenance program should also include provisions for training personnel on the proper procedures for inspecting, cleaning, testing, and repairing the equipment. By implementing a comprehensive maintenance program, organizations can ensure that their electrical equipment is operating safely and reliably and that it is protected from damage and deterioration. Section 110.12c is not just a set of rules, it is a framework for ensuring the safety and reliability of electrical systems. By understanding and implementing the requirements of this section, we can create a safer and more efficient electrical environment for everyone. Let's consider some specific examples of how these principles apply in different contexts. In a commercial building, electrical panels are often located in basements or utility rooms, which can be damp and dusty environments. Regular inspections should be conducted to check for signs of moisture, corrosion, and dust accumulation. The panels should be cleaned regularly using a vacuum cleaner or a soft brush. The connection should be tightened to the manufacturer's specified torque values. Any damaged parts should be replaced with approved replacements. In an industrial facility, electrical equipment is often exposed to harsh chemicals, high temperatures, and heavy vibrations. The equipment should be protected with suitable enclosures and coatings. Regular inspections should be conducted to check for signs of corrosion, overheating, and damage. The equipment should be cleaned and maintained according to the manufacturer's instructions. Any damaged parts should be replaced with approved replacements. In a residential setting, electrical panels are typically located in garages or basements. While the environment may be less harsh than in commercial or industrial settings, it is still important to conduct regular inspections to check for signs of moisture, corrosion, and dust accumulation. The panels should be cleaned periodically using a vacuum cleaner or a soft brush. If any electrical work is performed, it is essential to ensure that all connections are properly tightened and that all components are in good condition. Furthermore, it is important to educate occupants about electrical safety and to encourage them to report any potential hazards, such as flickering lights, sparking outlets, or unusual smells. By taking these steps, we can create a safer and more reliable electrical environment in our homes. In conclusion, Section 110.12c is a vital component of the National Electrical Code. It provides a clear framework for ensuring the integrity of electrical equipment and connections. By following the requirements of this section, we can prevent electrical hazards, protect our employees, customers, and assets, and create a safer and more reliable electrical environment for everyone. Remember, electrical safety is not just a matter of compliance, it is a matter of life and death. By taking the necessary steps to maintain the integrity of our electrical equipment, we can make a significant difference in protecting ourselves and others from the dangers of electricity. Always consult with a qualified electrician for any electrical work and follow all applicable codes and regulations. The information provided here is for educational purposes only and should not be considered a substitute for professional advice.